Alrighty, hey, what's going on, guys? Welcome back to another great stream. Now, you guys might be wondering, Potato, what the fuck is this stream, dude? What the hell are you doing, my guy? And to that, I say this. I have homework due today. I have two homeworks due today, actually. One of them involves me doing things, and the other one involves me doing other things. Sorry, my Twitch is being a little weird. Give me a second here. What the hell? Shield mode, manage your stream, clip that animation, shoot marker. How do I view my actual stream preview? There we go. Hello, hello. There we go. Cool beans. All right. So anyways, I have homework to do. And I need to do it because it's homework. So yeah, you guys could have watched me do homework if you want. This is gonna be a very laid back stream. Honestly, probably one of the most boring ones. But hey, if you guys are ever interested in engineering or mechanical engineering, any type of mechanical aspect of engineering, then you might find this video a little bit interesting. Yeah, some of you guys might even have some experience in what I'm about to do. If you guys don't know what Fusion 360 is, I believe it's a CAD software. Let me see, is Fusion 360 CAD or CAM? I'm pretty sure it's a CAD software. Yeah, so, well, yeah, it's CAD software, but has integrated CAM software abilities. So, what Fusion 360 is essentially, you think of something using your big brain, right? Your big mega cranial brain. And you're like, holy shit, I gotta make this. But how the fuck do I make it? Well, you can make it in here. Fusion 360 allows you to create anything that you want using whatever various materials you want, using different using metric systems such as EU standards or United States standard system. And yeah, you're gonna make it. And this lovely software that I have taken 3 classes over. Probably going to be 4. But anyways, for one of my classes, it is called 380. Computer-aided manufacturing. I have to recreate an object. So, due to a bunch of shit, I'm going to download this homework so that you guys actually, I don't actually show it. Here we are. Boom. Alrighty, so let's go ahead and boop. So this is the homework. I am presented with a design drawing here for this random ass part that looks like this. Figure 1, the material it's made out of, and the unit that I have to bring it in. So whenever I design this unit, whenever I design this figure, all the links, all these little links you see here, 25, 25, 10, all these little links, they're in millimeters. So I need to make sure that they are all, whenever I design this object, whenever I design this part, it's in millimeters. Also to make sure that it is in 304 stainless steel, and that I meet all the parameters for all this. So assignment student when drawing to show 4 views, front, top, section, and isometric. Section view must show both the 7.5 diameter and 20 diameter holes. So let's see where that is. The 7.5 diameter. So this is the 7.5 diameter. All 3 of these are 7.5 diameters. This is 3x 7.5 diameter. So these are all 3 7.5 diameters. Let's show both a 7.5 diameter and 20 diameter holes in their depths. 20 diameter hole. That's 15 diameter. Wow, there is no 20 Diameter hole. I don't see anything. Yeah, I don't see a 20 diameter hole. I see a 15. I don't see a 20. Unless I'm high. Nope. I'm assuming that he meant to say 15. Probably at 15. But if that's the case, then I'm gonna have to do a different kind of cut. I'm gonna have to do a 90 cut. Mid-hit and mid-lines that are symmetric obviously include dimensions and GD&T requirements in your drawing as stated in the notes without rewriting it. So GD&T is essentially a format for it is a format for what do you call it? The max or min, but there's a special word for it. It's a simple word. I forgot the name though. Tolerance. There we go. It is a special type of tolerance. It's not the tolerance of the size that can be manufactured, but it's a tolerance for there's different types of tolerances, and GD&T essentially is a category of different types of tolerances, such as angle, hole, blah blah blah. Use a CAD software. Your choice to enhance sketching your drawing. Use third angle projection rule. We're using A4 paper and all this boring shit. Cool. So here we are in Fusion 360. So first what we need to do is we need to set the unit of measurement for our design here. So we're going to go ahead and go to document sentence. The unit's already in millimeters. You can see right here. So don't have to worry about that. So let's just get started. So according to the front of this thing, I think I might get started on drawing the side of it actually. I'll get started on the front. I'm gonna access the front like this. I'm gonna go ahead and create a sketch. So we're gonna do a rectangle here. Start from here. So this thing is 70 wide, 70 millimeters wide, and its height is 15. So 15. There you are. And yeah, so now what we're gonna do is we're gonna finish the sketch. I'm gonna go ahead and extrude this guy. How thick? It is 50. So it is 50 depth wise. We have a little cube here going on. Now it does have a little hole in the middle, so and that is 30. What is the height of this? Remember, here so you guys can see we have this little hole here. Let me kind of zoom it in. We have this little hole here, which is 30 wide. It is 3 in depth. So we're gonna go to the left side here. What I'm gonna do is I'm gonna create another sketch, and it is going to be see here. How big was this thing? 30, right? So that means there's 10 between this and that. That distance here is 10. So what I could do is I could do here, I could say that, hey, this is 10 millimeters. All right, that is, well, let me do a line instead. My bad. Let me do it here because it's not the origin. This is 10 millimeters, right? We can ignore that. This is 30 millimeters. Boom. Grab this guy. Go. Leave. Be gone. Look at this. We'll do a rectangle for this guy. This guy will be 30 millimeters, and this guy will be 3 millimeters. There we go. And then we could say, you, be gone. Fuck off. Get out. And get rid of these dimensionings because it's a bit annoying. And then what we can do is we can click on extrude. Now this time, whenever we extrude this guy, oh, wrong plane was selected. Whenever we extrude this guy, it is going to delete the material that it overlaps. So what we can do is we can go into the front side, drag it all the way across. Okay, and now we have our little cut section here. Cool beans, right? Very cool beans. Now we're going to grab our. Let's see, what else do we need? So this thing has a height of all the way from the bottom, that's 55. But I wonder, does he have anything from this plane? Yeah, and above. No, he doesn't. Okay, so this height from here to here is going to be a total of 55, but we already have this base, so it's going to be 55 minus that, which is 15, which is 40. So we're going to have a total height of 40. So we're going to go ahead and go to the left side here, create another sketch. Let me see if this guy, let me go ahead and, where is it? Let me create, where is it? I go to construct and let me see if I can find, where is it? There's a way to ensure that, so this point is not directly in line with this. If I zoom in closer, you can see that there's a bit of an offset here. So in order to make sure that the next part I create is directly on that, there's going to be a circle here. You see that little circle? Sometimes some parts won't have circles. So let me see if I can find one. That one has a circle. These are simple vertices, so these guys will have circles. But if I were to create like an awkward triangle, then it won't have that. So just to ensure that this is a point that I can kind of latch onto, I want to make sure that there is a point. So boom, boom. Okay. Now that point is there. And I'm going to go to solid, create a sketch, select my plane, which is definitely not that. This is my plane. And we're going to create another rectangle, and it is going to be a height of 45, like we said. And the thickness, let's see, what was the thickness going to be? 10. So it is going to be 10 millimeters thick. Just go with 10 there. All right, and of course, this is extruded all the way to the end. So we're going to go ahead and extrude this boy all the way to the end as well. Just like that. Coming together, you know? It's not perfect, but it's coming together. So now let's go ahead and create our, I want to create this triangle. I'll focus on the holes later. How far do these triangles extend out to? 25. So they are 25 out. So if I go to left here, but I do need to figure out the height of these triangles. So they go 25 out, right? No, wait. They go 25 out. How tall are they? That's the question. What is the height? They do not give us a height. We can do math to figure out the height. But if they provided it for us, that would have been a lot easier. They gave us the angle, which is 30 degrees. So we can do some math. So because this is an engineering stream, and I want to show you guys every step of the process when it comes to designing this fucking object, I'm going to whip out the Galmon tablet, and I'm going to show you my math. Don't worry, it's not anything complicated. It's just a little bit of trig, but I'll be right back. Alrighty, so we have my beautiful tablet. Alright, so grab this baby. Where the fuck is hiding from me? How dare you?
How dareth you hide from moi?
Are required to be in my possession when I request it. Ugh. I need this tablet, not just for school, but for my personal projects as well. So if I can't find that's a bit of a problem now, innit? There it is. Found it. Cool beans. I had a feeling it'd be over here. Alright, so I'm going to disconnect something random. Probably going to be this guy. Gone. I'm going to connect this guy. Alright, I got my Galmon tablet connected, ready to go. So what I'm going to do is I'm going to whip out a notepad or a drawing. What the fuck? Whoa. What the extra shit just fucking happened? That was weird. Whatever. Drawing. Alright, we'll do paint 3D. Can I do 2D on this? Because I kind of need that. Hopefully I can. Okay, cool. I can. So let me go ahead and grab this little eraser. Okay. Make this eraser bigger though. There you go. Alright, so here's what we know. We know that our little triangle here is 25 wide, has a base of 25, and is 30 degrees. So we have a triangle here. Let me draw it according. We have a triangle here. The angle right here is 30 degrees, and the base it was 25, was it? Yes, it was 25. So its base was 25. We don't have to worry about unit. We don't have to worry about units because everything's in the same unit. So now I'm going to grab my handy dandy TI-84 calculator, because if you're an engineer, you probably have one of these hoes. Some kind of calculator. Graphic calculator. Don't use them bitch ass calculators. So we don't know what this is, right? We have no idea what this is, and we don't know what this bitch is. We don't really have to worry about those. This is an alpha, by the way. Alright, it's an ugly alpha. So, how the fuck do we find out what x is? Well, we can find out what x is because we know that TOA, TOA, tangent, opposite over adjacent. We know that tangent of 30 degrees equals to opposite over adjacent. In order to find x, 25 times tangent of theta equals x. Simple, right? So now you grab your calculator and you do 25 times tangent of theta. Would you look at that? 14. Well, actually, it's an ugly ass number. It's not just 14, but you get the idea. So what we're gonna do, right? By the way, this 14 that we calculated, let me write it out for you, I guess. Tangent of x equals 14.4337567. Oh. Here, ignore this. Let me write it like right here. X equals 14.4337567. Now, obviously, whenever I go to write, whenever I actually go to fucking input the height of this thing, I'm not gonna write this big ass fucking number. I'm gonna write a tinier number because this is a pain in the dick. So what I'm gonna do is, and by the way, that height that I just mentioned goes from the bottom, not to here, but to all the way to the top of this triangle. That's how that works. So we're back in Fusion. We're gonna go ahead and create a line of the base was 25 and the height, or we could just actually do this, honestly. We don't even need to fucking calculate that. We can just do 30 and just bring it all the way there. And if you notice, when we go to the bottom, you get that exact number we just calculated for, 14.434. Boom. Didn't even have to do math. But you know what? It never hurt anybody. That's a lie. Math hurt a lot of people. It's actually hurting me right now. That's probably why my head's stuck in math. And it is 10 thick. So we're going to go to extrude. And we're going to do it 10 millimeters thick. Now what I'm going to do is this little guy right here. Oh, it's fine. I was gonna copy that object and then just paste it on the other side, but I mean that works too. Unless I can just copy it face. Okay, do that. Move the face. Oh god, that is not what I want to do. No, it's officially part of the object. Unless I could copy the face. No. By the way, in no way, shape, or form am I a master at using this software. I have a lot of holes in my knowledge, and honestly, I tend to go the harder way, which is a very bad habit of mine. But what am I gonna do? Anyways, here we're gonna have 25 with a 30-degree angle, all the way top, connected down, and we have our sketch. We're gonna grab this guy and extrude him -10 because we're going in the negative X direction. And there you are. That is our little guy. That's our little dude right there. So now we're gonna create our holes. So I'm gonna delete this guy because we probably don't even need him anymore. Don't save. We're gonna create a hole right in the middle. It is going to be 22 out. And how far in? It's probably gonna be right in the middle. It is because you see this little plus sign. That essentially is a center line. So these center lines tell you that they are not only just a perfect circle, but exactly that it is in center of this entire thing. So we're gonna go with the assumption that it is in the middle of 70. So 70 divided by 2 is 35. So it is 22 high and 35 to the middle. 22 and 35. Those are the numbers. So we're gonna go ahead and go to the top here. I might be able to get away with doing a construct here. Probably not. I'm not too familiar with the construct, so I'm gonna just do it the way I usually do it. We're gonna go 22 top and 35 in the middle. That is the exact spot where we need to do this. So now what I'm going to do is I'm going to delete these first of all. And I'm going to go to construct, point at vertex, click this guy. Okay. And if I delete this line, you'll notice that that little circle is still there. So I'm going to go ahead and go to hole. Could just latch right onto there. That is strange. Fusion is lagging. Oh no. Okay. Let me go ahead and save this before it crashes. I lose all my progress. 380 homework. What is this? 8? 8? Yeah, homework 8. My circle has disappeared. Let's see what's going on with the circle. Go ahead and let me just backtrack actually. The circle's still there. So let me just finish sketch. We go to construct, point at vertex, click that. Okay. Still there. Delete. It's not there. Interesting. So let's go to construct. You can't do point at vertex. Point along path. What that? What is it at the very end? All right. Nope. That's fine. We can just keep the line. And then we'll go to this. We'll click on hole. Hole right in the middle. Or hole. Like the plane. Been selected. And it won't snap. Gotta love Fusion. Let me go to sketch. Actually, let me just go to edit sketch. Hold on. This is sketch, right? Oh, go ahead and edit the sketch. Create another line here. Goes all the way to the bottom. And then let's see if we can do that other option now. The point through 2 edges. This guy and this guy. Yes. Point there. Let's see if we can create a hole now. Okay, that works. It created it at the bottom, but that's fine. Ugh. So let me go ahead and move these two guys up if I can. I'm gonna move them up by 15, I believe, because that's how big this dude is. Yes. Click OK. Top view and just create another hole. Now the diameter of the hole, you can see it goes by diameter, doesn't go by radius. The diameter of this hole is 15, so we're gonna just type in a solid. That's depth, diameter, 15, and we have a 15 diameter hole. Yay! You can change this the way, like the tip if you want. You can make it a tip. You can make it you know, what the fuck that is. I don't know, but you can do different shit with it. Let me make it all the way down just to ensure. Yeah, hole. Boom. The holy hole. That sounds really bad, but I'm gonna stick with them. Let me make sure that's see that? It's 14. Needs to be 15. There we go. I was gonna say I feel like I fucked that up somehow. I'm not gonna realize until the very last second. Alright, so we have that hole. Let's go to the front and create 3 holes at the top here. We're gonna go to hole. Actually, we're not gonna go to hole. We're gonna go to create sketch. We're gonna create this plane. Or select this plane. We're gonna go to here and 10 down and then 25 apart each. So 10 down. Let me go ahead and do this. 10 down, totals 55, so 45. Somehow that don't look right. Let's see. It's 55 all the way to the top, 10 down, 45. Just to make sure this is 55. It is not 55. Why is this not 55? What the fuck? Did I math incorrectly by accident? Let me see. How tall is this? That's 45. That's 15. 15 minus 55 is 45, right? Oh, it's 40. I'm stupid. Okay, we're just gonna delete fucking 5 off of this. We're gonna make the 70 long. We're gonna do 5. This guy. Well, you know what? We don't even have to do that. Just what was the thingamajiggy for this guy? This is the extrude to edit the sketch. But for this one, we're gonna make this 40. There you go. So now that should have fixed that. Now whenever I go to remeasure this, it's gonna be 40. There you go. Cool beans. So that is 40. Which means that whenever I do this, all the way from the bottom, it should be 55. There you go, 55. So we need it to be 45 because it's 10 down. And then it is 10 across, 25 from each hole. So from here to here, it's 10 and then 25 each. Cool. So we're going to do 10, right? And then we're going to do we're going to do a 25. And then a 25. And I'm going to go ahead and delete this sucker. And I'm going to go ahead and create points along these surfaces. So I'm going to go to construct. Point along a line. So I'm going to go here. The distance is weird. Let me do physical. Yeah, that was a weird distance. All right, we'll do okay. So there's a point right there. We'll do another point along a line. And then we'll do 25 right here. That's 22.5. We don't want that. We want 25. Right there. And then we'll do another point along the line. This one's going to be... Wait, that's not 25. Hold on. That is not 25. It's 25 plus 10. So it's 35. So this is going to be 35. And then if we mathed everything correctly, 25, 25, 50, plus 10, 60. So the end of this line should be 60. And it is. Look at that. So these are the locations of the holes. We're done with that. We're going to go ahead and create our holes now. We can easily do that. Now the diameters of these holes are going to be 7.5. So we're going to do 7.5. A 7.5 diameter. And yeah, that's right click OK. We're going to go to hole. We're going to create another hole. More holes for everyone. And that is 7.5. Cool. It snapped onto there. Up to point. 7.5. We're good. All right, so we got our holes. Now you notice that our image here is a bit round. You know, it's round here, it's round here, it's round here. How do they do that? Well, these little rounds right here at the end of these triangles are called fillets, filet mignons. And let's get started with those first. So we're gonna go ahead and create 2 fillets right here. So what we're gonna do is we're gonna go to click here. We're gonna make it a bit bigger. Now we need to know the radius of this. It could be big as fuck, or it could be tiny as shit. What's the radius? Well, if we go to this little thing right here, you'll see that fillets and rounds are 5, meaning there is a radius of 5 for all fillets and rounds. Boop. That's it. Literally it. And it's not 2.5, because 2.5 would look like that. It is radius. So we are going with a radius of 5. That's it. And do the same thing right there. Now, for this guy, we're going to do what's called a, I guess it's technically called a fillet too. Oh my god. Holy shit. We're going to do that guy. Like that. This is also a fillet, but it's a fillet of 5. Like that. And like that. And would you look at that? Was that hard? Not really. That took like, how long did that take? 30 fucking minutes. Yeah, that's really it. I mean, look at the fucking drawing. That's the same shit. We could even do a little side-by-side comparison here. You know? But now some people are gonna be like, well, potato, what if you did some of the dimensioning wrong? You know, what if one thing is actually bigger than the other, or one thing's not as big, you know? It's exactly what your mom said to you, but you know what? I'll prove that this is the same dimension. So what we're going to do is we're going to make this guy full screen, minimize it, make this guy full screen, and we're going to create a design drawing. We're going to go ahead and, first of all, this thing is made out of, what was it made out of? This thing was made out of 304 stainless steel, so let's go ahead and assign that. So right now this is made out of like, it's made out of like regular plastic. Let's see what it's made out of. We'll go to bodies. Select it, right click, and we'll do physical material. So right now it is made out of steel. We don't want it to be made out of steel. Whoops, wrong button. We're gonna go to metal. We're gonna go to 304. What was it again? I already forgot. 304 stainless steel. Yeah, 304 stainless steel. I gotta scroll all the way down through stainless steel. 303, right? 304. Stainless steel is AISI 304. We're gonna go ahead and drag that onto there, and you'll notice that it changed color slightly. That's because it is now, well, that. If I were to change it to steel, it'd be darker. Stainless steel, lighter. And we can ensure that it's the correct material whenever we go into our design drawing. So we have, that's all, everything is in millimeters. What the fuck is this? I don't know. Okay. We've ensured that it's in millimeters. We've ensured that the material is stainless steel. The 3 7.5 holes are parallel to 0.4. Okay, so these are just the parameters of the GD and T requirements for the assignment. So we can worry about that. So we're gonna go to design. We're gonna go to drawing. From design, just like this. We're gonna choose a 4 paper. Should be this guy. Let me see if it's this guy actually. If it's very vertical, it's the wrong one. It needs to be very horizontal. Units are millimeters. There's 2 standards. There's ISO and there's ASI. Or AISI. I think it's called AISI. I forgot. I'll remember whenever I see it. You know? So it's thinking. My computer's handling a route. It's handling a route right now. Handling a lot right now with streaming on 2 platforms and a CAD software, so give it a break. My headset just died. That is absolutely beautiful. Might as well charge it. Why the freak not? It's not like I was listening to any music anyways. It was just lab. Come on, Fusion. This is the wrong paper. So, this is very long. We want it to be very wide. We're going to delete this guy. Don't save. Design. From design. We're going to do this guy. ASME. That's the other one. So, we're doing ISO millimeters. And we'll go ahead and create it. That was a lot easier. So, he asks for a front top section and isometric. Top front isometric. So we're going to do a front. I'm going to make this a bit bigger. So got to change the scale up here. Oops. Do a 1:1 scale. We're going to do, this is our front. Right. We're going to click projected view, top view. And then we're going to do a isometric view. Do an isometric view. We're going to change the scale for this one. We're going to make it 1:2. 1:1.5. Better. And then we're just going to make this solid. Solid boy. Wow, I am lagging really fucking badly. I'm gonna let my computer think before it crashes. Brain deterioration is a problem. We're gonna kind of move this guy right here. Now, let's go ahead and start dimensioning this. So we have a little dimension tool. We can just press D and it pops up. And we're going to label all the dimensions of our guy here. So if we did everything correctly, it should match up with what we have in the homework. So we're going to do this guy. We're going to do right here. Now, instead of dimensioning every single circle at 7.5, that's unnecessary information. But we can just double click this. At the front, we can do 3x, comma. So what's that saying is that there are 3 of these 7.5 diameter holes, which is exactly what's seen, which is exactly what is seen here. You see 3x, comma, diameter. Now, what's kind of really annoying is the fact that this line looks really fucking weird, and there's a way to change it. So let me delete that, actually. I'm going to do, that'll help. Yeah, so much better. We'll do that. That. No. Text. Oh my god, so much better. Okay, we'll do that, and then we'll get rid of this. And then 3x, comma. Oops. Closed. And there. That looks just so much better. Just looks cleaner. It's just better, okay? Full thread and no. Is there a difference between this one? Really? I'll just delete that. Anyways, we're gonna create another thing like this. This time for this guy. Kind of one right here. Kind of yank him here, and then we'll get rid of that dealio. Close. There you have it. And then let me fix guy. Oh. There you go. That works. It's at an awkward angle. Don't want that. All right, now we're gonna go ahead and add some center marks. So we're gonna go ahead and that. We're gonna do this and that, this and that. This is not third angle. That's a bottom view. Wait, is this the difference between difference between ASME and ISO, dude? Or yeah, ASME. Yeah, ASME and ISO. Oh, wait, we're not supposed to do ISO, are we? Software. Third or first angle? Okay, third angle. So top view should be like that. Okay. So poop. This is all poop. So what we need to do is, this is why you get shit right. Oh wait, actually, I can't reverse it. It's fine. We'll go to from design, ASME millimeters, and then the correct paper size. So you'll see the difference between ASME and ISO here. We're gonna change the scale from 1 to 2 to 1 to 1. Do that. So now whenever I project the view, it's gonna look like that. You see how on the previous one I had to drag it to the bottom to look like that? That's because it was first angle projection. This is third angle projection. Big difference. I also notice the same thing whenever I do this guy. It's in the orientation I originally wanted it whenever I dragged it to that 1.5 scale. Smaller. Drag this guy down, drag this guy down as well. And then we can do the same thing for the text. Just kind of blurp, blurp. X, Y. Here. I like how there's no line or anything now. That's fucking beautiful. And then we'll do this guy. Well, how did he originally do? Well, he did it in isometric, so like this guy. Close. Let's do our center lines. Do a bunch of center guys right there. Do some guys as well. Boom, 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 boom. And since they are equal sides, what I'll do is I'll go with this. So that it shows that this entire fucking place, all the way bottom here, all the way top, is equal on both sides. And I can go ahead and do this. Just to show. Now, this may or may not be legal when it comes to line drawings. God, if this, I'm gonna go ahead and do it and double make sure with one of my good friends that this looks right. Yeah, that's that. So what we're gonna do is we're gonna also do some dimensioning here. So we're gonna say that let's start with the top view. This guy is 10 thick boy. We'll say that this there, that is 10 away from this guy to guy, right? That's 25 away from this guy to that guy. Away. This guy's in the way, so we're gonna go ahead and drag him right here. That doesn't look bad. Then we're gonna go ahead and do some dimensioning. We're gonna say that from right here to here is 25. we're gonna say that from right here to right here is 10. And we're gonna say that the total length here is got a little. Just that we have enough kind of guy. If I oh. Actually, I'm gonna do. What the hell is this? What in the tarnation? Okay, it was that easy. Okay, that total is 50, and then oh yeah, we have to add text as well. We're gonna add a text right here that says right here. Fillets and rounds are 5. R5. Block. Increase the size of this boy. 5. Actually that works. What I'll just do is I'll just take this. Fuck. Why the fuck did it do that? Weird. Size of that. Do that. This. And then increase this to 15. 15. Yeah. Cool. So we've showed that all the fillets and rounds are 15 or are 5. We'll go ahead and start. We'll go ahead and dimension the bottom portion here. So we'll say that from here to here is 70. We'll say that the total height, which I have from here to here is 55. So that this guy from here to here is 50. And we'll also say that from here to here is 3. You want to change? Don't like it. So what we'll do is we'll change it from bottom to top to bottom. Oh. Oh. The 3 goes on the left, but I don't want to go. That's where my stop. Not fun. It's not cool. It's not cool. All right, you're not impressing anybody here, buddy. Buckaroo. Here's what I'll do. Delete. I'll take this guy, drag him out, and then I'll just dimension. It's not the prettiest, but it's what we got. So yeah. So now, with all this information, be able to someone were to try and let me do dimension this guy though. Remember the number we calculated? Gonna be a bit bigger on this one. Reason being is the fillet. Fillet changes the number. So for example, I don't know if I can dimension. Yeah, I can't. Guess we can leave that part. How wide this guy is. So that is also going to be very, very, very important. So we're going to go here and do this guy 30 here. That, this guy, got a little bit there. This guy, go all the way over here, and then I'm going to a wonk kind of deal. That. There we go. And so we've labeled everything on here so far. The thickness of this, yes, we did. Oh, distance of this center circle. So that's also important. So from here, 22. So your design drawing, that's true. So we'll right. Things are gonna get a little bit messy with the lines, but you really can't help it. I mean, this is a pretty clean design drawing that I've seen. I mean, this isn't the worst. Trust me. What else? I'm trying to think what else, but honestly, this is all I can think of. I already done that. There's literally just it. Go ahead and save it. Or my computer decides to have a seizure and fucking eat everything. It's happened before. Fucking terrible. I can dimension angles. Good dimension, but I'm not sure. See, that's not what I want. Oh, wait. Let me do. How the fuck is that 21.6 degrees? That is not 21.6 degrees. Let me go back to the fucking drawing. I literally did this. Like the plane, right? I literally typed in 30. What the fuck? Oh, wait. I forgot the fucking thing made it different. Let's do 30. Oh, yeah, it's different. 60. Wait, 180 minus 30. That's one. Yeah. Actually, the fillet made it. That's why it's a bit bigger. It's because the fillet made it. So that's just. But it is the 30. So the way he did it is he did that. But I can't. Not allowed to dimension. The reason I'm not allowed to dimension that is because of reasons. Just something you don't do on design drawing. You dimension the part where it's actually you can see. But we don't have a left or right view. We're just supposed to have a front view, a top view, and an isometric, and its section. So let's go ahead and make it the section, I guess. What are the parameters for the section? Section view must show both 7.5 and 12. There's no 20 diameter hole. I don't know where the fuck he got 20s from. It's probably a typo. So, and their depths. So, what we need to do is we need to make a to show their depth as well. That's we're gonna go over here to section view. Let's see if we'll start from here. There. There. That looks great funky. Start from here. Try it again. Huh. That shows their depth. Maybe I can try this one. Here. Why does it do that? Why is it going up? Stop doing that. Okay, that shows its depth. Cool. I can work. So we have this guy. Isometric. Section. The other section view. Now you are allowed to dimension section views. That is 100% allowed. This cross-sectional area just shows that this is solid material. So what I can do now is I can actually now do that angle thing that I was talking about. So I can go ahead and do dimension. I'm going to do an angular dimension. Here to here. And would you look at that? It says 30 degrees. Beautiful. And I'm actually going to delete some of the... Should I? Should I? I don't know. I could, because it's quite clustered up here. I might leave it, honestly. I'm gonna leave it. This looks pretty halal to me. And yeah, that's pretty much it. So that's all the dimensioning, I think, for this project. Now we do have to do the whole bullshit here. So I'm gonna rename this homework. How did I actually do the previous? Let me open up another homework just to make sure that I'm fucking doing that doing the simplest part properly. I'm done. 2 380. Oh, we'll just do this. Fine. See, like, this is a nasty one. This is a lot of fucking dimension. This is a clusterfuck. Absolute clusterfuck. And honestly, I could have transferred some of these to here, but I didn't. So that's what he wants to format it like. So I'm gonna go ahead and I'm gonna copy it. But what did he call this? So what was this part called? Let me see what this part was called. The part was called square anchor. So we're gonna go ahead and project square anchor. This shall be homework 8. MMET at 380. Yeah, L90 pitch. Wait. This is homework 8. space. Every little detail matters, man. Makes a huge difference. Material unit scale. Okay. Go ahead and do material 304 stainless steel. What was it? Material and something. Material unit scale. Material unit scale. I forget. 304 stainless steel unit. For the most part, it's 1 to 1. 1, 2, 3. Scale. Oh, wait. Scale is 1 to 1. Honks. Unit is millimeters. Cool beans. We have our material, we have our units and our scales. And you can confirm the scale at the bottom if you want. Go ahead and save this guy. Oh, something else that is very, very importante. This guy. Wait. Insert image. Go to for my computer, desktop. It is called third angle. So there's a symbol that you are supposed to include on every design drawing, and it is essentially whether or not your design drawing is in third angle projection or first angle. And this is a third angle projection project, so you have to include the third angle projection symbol, which is this guy. You can see I did on this one too. This one was in the first angle though. Like if I were to do this, yeah, does that. Wait, now I think I fucked up on this. I fucked up. I don't make sure that the third angle projection symbol. Third angle projection symbol. Symbol. Should be pointing towards the circle. Yes, and it is pointing towards the circle. Now, first angle gonna be pointing away from the circle. Bad. See, looks like imagine this little triangle or this little trapezoid here is an arrow pointing away from the circle. This is third angle. That's first. Oh, I'm assuming there are some projects. Sometimes they throw at us a first angle projection project, but it's a pain in the dick because first angle is primarily used by the EU or literally any other country than the fucking United. The United States is dumb in a lot of aspects. One of them being it has its own standardized units called standard instead of metric. It also has its own projection view. Third angle projection. Many other countries use first angle instead of third, but I mean it is what it is. Oh, can't really complain about that. Legally, I can't. And yeah, that is the project right there, guys. Pretty easy dub, no? Pretty easy dub indeed. Whoa, that is oogly. See, I hate how that goes out. Like that bothers the fuck out of me. There is a certain type of cross hatching pattern for stainless steel. I guess I could do cross hatching design for 304 stainless steel fusion 360. Stainless steel. So it is this guy. That is a cross-hatching. It's ASI 32. So we can double click this and change it to 32. There are different types of patterns for the material. That is definitely good to know. Well, that's it. I don't know what else I can do. Took us like a solid hour. At this point, it's just little minute details, but I don't really know what else I can add. Oh, the fucking main part of this equation, this thing. The notes, the three holes, 7.5 are parallel to 0.14 millimeters. So I'm gonna have to whip out my book for this because I don't properly know GD&T GD standards. Something that we're going over right now in class. Now I've been paying attention to class. If you guys want to know what kind of person I am when it comes to college education, I'm the guy who sits in the back of the classroom with my friends, like, and we're pretty rowdy. So like whenever it comes to exams, the professor usually always looks our way to make sure we're not cheating, and most of the time we are not cheating. The professor usually looks at us, and he always suspects the people who are, you know, good friends with each other and a little bit rowdy to always cheat on exams. I don't know why. I've never cheated on an exam, and for some reason professors love eyeing us down. We do sit together though, but I mean, I don't look at the other guys' papers because I'm gonna fail my exam if I do that. Not saying that they're stupid, because honestly, some of these guys have actually some of them have better fucking exam scores than me. But we sit together and during class, that is, you know, one guy will be actually focused, writing down notes. The other guy will be just kind of like looking up and down, or scrolling away on his computer, you know, shopping or whatever. Me, I'm the guy who busts out my fucking phone and starts playing Balloon Tower Defense battles in the middle of lecture, occasionally glancing up at what the professor's talking about. But I know that it is an 8 a.m. class. I'm tired as balls, and this man fucks his students on tests anyways. So even if I were to pay attention, I don't know. It would pretty much give me the same shit. But he does have a little handout book for his classes, which is, I guess it helps. But so anyways, we're doing GD&T. So we did all that. Include dimensions of GD programs and join the notes without rewriting it. So the three 7.5 holes are parallel to 0.14. So if I can find the proper bitch. These are tolerances that I'm dimensioning here. So let me do that. The fuck? Woo! What the fuck is that? Full thread note. Change the way this looks. There is section specifically for GD&T. Let me see if there is. I'll show you what GD&T looks like. How to create GD and T symbols. In drawing workspace enthusiasts, you can use a command in the symbols panel on the toolbar to add GD and C symbols to sheets in a drawing as you do. What? That's what I want. That's exactly what I want right there. How the fuck did he do that? What? It's in the symbols panel. Symbols panel. Is it surface texture? Is that the one? Feature control frame. But that doesn't, that does this shit. Which, like, just creates an infinite amount of fucking squares for some. Maybe I have to just press enter. Okay, there we go. So we want to do, what did it ask for? Parallel 14 millimeters. So we're gonna do parallelness. Parallelism. And then we're gonna do, the first tolerance is gonna be 0.14. That should be the doohickey do. First datum. I think that's it. I literally think that's it. It's just that. And then what else? The point of both surfaces A are flat to point with a maximum surface finish of 1.2 micrometers RA. Okay, so let me do this guy. This guy. I like that. I do not like that. Let me do that. Wait, that. There you go. Parallel to Wonk. Let's see. Both surfaces A are flat. So we're doing flatness. Flatness. To 0.5 millimeters with a maximum surface finish of 1.2. So to 0.05, I believe it was. 0.05 millimeters with a maximum surface finish of 1.2. Okay. Second tolerance is look at parallelism. I'm glad I don't have to do fucking tolerance for all the fucking things. That would be a pain in the dick. Is there one for surface finish? No, there's. What is the symbol for? It's just. Let me Google it. GD and T. Maximum surface finish. Surface condition. Fusion 360. There's no pictures. Oh, what I want. That is not what I want. Ah. Wait. Closer finish. Oh. Pain in the dick. Okay. This is what I think it might be. This is the parallel, right? But I don't want flatness. We want all of a surface as well. So the second frame characteristics will be profile surface. First tolerance is going to be 1.2. What is that? First tolerance is going to be 1.2 micrometer. There is no symbol for micro. Just, probably gonna have to. Let me copy it. Micro symbol. There you go. Copy. I guess it was Alt code. Only that Alt key. Oh 0181. Okay. Alt 0181. I didn't do does anything. Alt 0181. Well, fucking did it there. There we go. Micrometer. Then we can move this guy a bit up, down. Entire fucking thing. Ring a ding ding. That is not my ting. I guess I'll have to do this. That works though. And then that guy. The hole 15 is perpendicular to the bottom surface A to 15 millimeters. So we want perpendicularity of the 15 hole to the A. The 15 hole to A. So we'll do this guy. Wait a minute, what the fuck? Yeah, yeah. Okay, never mind. We'll do here. Dude, there's like no fucking space for this shit. I'm gonna have to. I might have to. Yeah, I'm gonna have to transfer some of this shit over to there. There's like no space for this bitch. I guess I can just do it on the other side. I can just do it on here. Oops. We'll do frame. Frame. We'll do this guy right here and this guy right here. Press enter. Okay, we'll kind of move this guy a wee bit. Oh. I double click this. We're going to do perpendicularity. We're going to frame. And it is perpendicularity to 15 millimeters. 15 millimeters. 15 millimeters would be an insane tolerance. The fitting little C is round to 0.12. Round till 0.12. We'll add a second frame. We'll do roundness. Was it to 0.12? Yeah, point. I'm not even gonna add millimeter. So, means. And then what else? The distance 25 millimeters. Distances between are basic. Oh, interesting. Okay. So we'll go ahead and click this for this guy. Here. We'll do from that works. That works fine actually. Not move it. Weirdo. Blanc, 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 blanc. It just attaches itself. This will be weird now. No. Go ahead and save. How the fuck do I move this? Ask the fucking question. Delete. Delete. I'll probably have to do it from like here. Here. Guess that works. And then we'll do 25 millimeter basic. I think it's position. Bro, what the fuck? No, don't redirect. Okay. That was gonna be that was gonna open up fucking Fusion and like destroy my project. PTSD, guys, PTSD.
Okay, dimensioning. If I dimension this side and then this side, they're even dimensions so they don't
Okay.
come out the same. So you can turn on
Cool.
the decimal places down here, display decimals. Now, as far as precision, you simply double click on it. You can change the precision for individual ones like that, and the other one stays 2. As far as basic reference dimensions, same thing. If you go down to representation, you have reference dimensions, and if you go down the same place and you change that to basic dimensions, it puts a box around it. That seems to be all you asked for. Um,
That fucking it, bruh. That's how you do it. Is that all you do? First Google what the fuck that is. I just learned this like literally today, so quote unquote. No. I think it's just making them square. Okay, I literally just think it's just that. So we'll go ahead and delete that. We'll do this, and then we'll do tolerance. Whoa, not that. Definitely not. Theoretically exact. There you go. That's for the 225s. So get rid of that, dude. And I think that's it. 1 to 1 inch max. He did it in inch. Why? It's all in fucking millimeters. Dude. I insert the image. Okay, already won. Cool. On isometric drawings, yeah, that's what I did. I did that, did that. Select the scale of, yep. Most of the drawing paper. The first ways information, yeah, cool, cool beans. Yeah, that's it, guys. That's the fucking homework right there. Ah, finally, an hour and 30 minutes later, we are done. Woo! Now I get to play League. Because what better things to do with my life than play fucking Lego Legends? Ah. Also, I do want to kind of experiment around with some other things. But for now, I'll go ahead and send a picture of this to the homies. Damn, my DMs have been blowing the fuck. Go ahead and send an image of this. Oh. Drew said, bro. He's gonna be like, what the fuck are you streaming? I asked so much done last night. Oh. We send this to the homies though, just to make sure that they got similar results. Okay. Sorry, I just have to respond to all these fucking messages. All right. Okay. Now that all this shit's done, cancel. We'll just delete. You don't have to do. You don't have to do shit. Update later. Yay! Fucking finally. One. Every time I download an image, it like shifts everything, and it's like the most annoying shit. It does that. All right. Well, the fuck is this program, bro? Hold on. What is this fucking shit? That's Task Manager. What is this? What the fuck is that? Oh, that's fucking Fusion. Get the fuck out of here, Fusion. I just closed you. Overwolf. Bye. 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 For some reason, Fusion still thinks that it should be open. I guess I could stay. Yeah, just doesn't want to leave. All right, well, I'm gonna recreate the stream, but this time I'm going to change the stream shit, majiggy things. So yeah, I'll be right back, guys, and yeah, beer.